The objective of this video is to identify the trigonometry ratios on the unit circle. Trigonometry ratios are useful for finding the ratio of two sides when you're given two sides, and then you can figure out what the angle was. Or if you're given the angle, you can use that angle to figure out what the ratio was. So the three ratios, the trigonometry ratios we're going to be using are sine, cosine, and tangent. We'll also be using just three angles: 30 degrees, 60 degrees, and 45 degrees. These are the most common angles that are used in trigonometry. So the first triangle we're going to look at here, it's an equilateral triangle. All of the angles are 60 degrees. That means all of the sides of the triangle are 2, 2, and 2. You can use a triangle that has 1, 1, and 1, but I'm going to use 2 here just for convenience of calculations. So I'm going to divide this triangle into 2, and we'll focus on only the triangle, the left half of this triangle. That means the hypotenuse of this triangle is 2, the adjacent here is 1, and then we have a missing vertical distance here, a height, and we're going to label it A. So to find A, we need to use the Pythagorean theorem, which says if you square the two shorter sides, you'll get the hypotenuse squared. So if I solve for A, which is one of the shorter sides, I need to take the square root of the hypotenuse squared minus one of the shorter sides. So if I substitute c squared with 2 squared minus 1 squared, I'll end up with square root of 3, because 4 minus 1 is 3. So now I'm ready to find the sine of 30 degrees. So sine of 30 degrees is up here. Sine of 30 degrees is opposite, so the opposite here is 1, and divided by hypotenuse. Hypotenuse is 2, so the ratio here is 1/2. And then we do the same thing with cosine of 30 degrees. Cosine is adjacent, so the side that is adjacent to 30 degrees is square root of 3, and then divided by the hypotenuse, which is 2. So that is the ratio. Finally, the tangent of 30 degrees is equal to opposite. So the opposite of 30 degrees is 1, and then divided by adjacent, which is square root of 3. We cannot leave this ratio like this, so we have to rationalize by multiplying by square root of 3 over square root of 3, which is going to be equal to square root of 3. So this is the ratio, square root of 3. So now let's do the same thing with 60 degrees, square root of 3 over 3. Now let's do the same thing with 60 degrees. Sine of 60 degrees is equal to opposite of 60 is square root of 3 divided by 2. 2 is the hypotenuse. And then cosine of 60 is equal to adjacent of 60 degrees is 1 divided by 2. So it's going to be 1 over 2. Finally, tangent of 60 degrees is equal to opposite. So the side that is opposite of 60 is square root of 3, and the hypotenuse is 2. So tangent of 60 degrees is equal to square root of 3 over the adjacent, which is 1, and that simplifies to square root of 3. Something interesting to notice about the ratios for sine of 30 and 60 degrees is that they are the opposites. So if you look at sine of 30 degrees is 1/2, cosine of 60 is 1/2. Cosine of 30 is square root of 3 over 2, and sine of 60 is square root of 3 over 2. So they are the opposites. And then tangent of 30 and 60, they are also the opposite. So 1 over square root of 3, and the tangent of 60 is going to be the opposite, or let's say the inverse, which is square root of 3. So the second triangle we're going to use is an equilateral triangle. So this triangle here, you can see that the two base angles are 45 and 45. That means these two sides here, the two shorter sides, are 1 and 1, and then the hypotenuse is C. So to find C, we're going to use the Pythagorean theorem again. The sum of the two shorter sides squared is equal to the longest side squared, the hypotenuse squared. So if I solve this for C, that would be equal to the square root of the shorter side, A, which is 1 squared, plus B, which is also 1 squared. 1 squared plus 1 squared is equal to the square root of 2. So I'm going to label C as square root of 2. And then now I'm ready to find the sine and cosine. So the sine of 45 degrees is equal to the opposite of 45 degrees. So it doesn't matter which of these two 45 we choose, we're going to get the same answer. So if I choose this 45 down here, the opposite side of 45 is 1. So opposite is 1 divided by the hypotenuse, which is square root of 2. So we have to rationalize that fraction and we get square root of 2 over 2. And then we repeat the process with cosine of 45 degrees. So cosine of 45 degrees is adjacent. So cosine of this angle down here is adjacent, which is 1, divided by square root of 2, which is the hypotenuse. And then again, we have to rationalize, and you get square root of 2 over 2. Finally, tangent of 45 degrees. So tangent is equal to opposite. So the opposite side of 45 is 1 divided by adjacent, which is also 1. So 1 divided by 1 is equal to 1. And these are the trig ratios for 45 degrees.